Alright, so like I said, chapter 4, if you didn't learn how to factor in chapter 3, you are going to have another opportunity to learn how to do it here. It's just now we're going to combine factoring with fractions. So everything that you learned how to do in 3rd, 4th, and 5th grade with fractions, we're going to do here, except we're going to use algebra. We're going to learn how to reduce them. We're going to learn how to multiply. We're going to learn how to divide. We're going to learn how to add. And we're going to learn how to subtract. And then at the end, we're going to learn how to solve equations with fractions. So, the first thing we're going to do is just to simply reduce. And we did some of this, a lot of it, at the beginning of chapter 3. So remember how we simplified a monomial over a monomial? This is just division. So there are some steps here. The first one that you're going to do is you're going to factor the numerator and the denominator if possible. Now, understand this. If you see addition and subtraction signs, not negative signs, but addition and subtraction signs, you can possibly factor. Not always, but sometimes you can possibly factor. So what I want you to do is I want you to look to see if you can factor first. This particular problem, you have monomials. There's no addition and subtraction, so you can't factor this. So step number 1 is already taken care of. Step number 2, what you're going to do is you're going to cancel any like factors. Now let's discuss what factors are. Factors are things that you are multiplying together. So in the numerator, I have 3 factors. The negative 28, the a squared, and the b squared. In the denominator, I have 3 factors as well, negative 63, a squared, and b cubed. So what you're going to do is you're going to cancel any like factors. Well, you know negative 28 and negative 63. What's a common number that will go into negative 28 and negative 63? 7. How many times will 7 go into negative 28? And how many times will 7 go into negative 63? So you have negative 4 over negative 9, which you know the negatives cancel each other out. So we're going to start off with 4 9s. Now in chapter 3, we learned how to reduce a squared over a squared. What happens? A squared divided by a squared cancels out, but what does it cancel out to? 1 or 0? Anything divided by itself is 1. Don't forget that. Okay? So when we mark something out, the a squares, they do completely go away, but they go to 1. And negative 4 times 1 is still negative 4, and negative 9 times 1 is still negative 9. Okay? So don't think that it goes to 0. There's a 1 there. Now, b squared over b to the 3rd. In the beginning of chapter 3, I told you it's always top minus bottom. And then if you get a negative exponent, you take the reciprocal of it. Okay? That you learned how to do in 098. I don't know that we've talked about negative exponents in here, but what I want you to see is this. Okay? On top, in the numerator, I have b times b. And in the denominator, I have 3 b's multiplied together. Well, watch this. 1 cancels 1, 1 cancels 1, and you're left with 1 in the denominator. Okay? So if you have 2 on top and 3 on bottom, obviously all the 2 on the top cancels out 2 on the bottom, leaving you with 1 more left in the bottom. That's why you get, that should not be a negative 3. That should be a negative 1. That's why you get negative 1 here. And it's b to the 1st power on the bottom. Okay. So here, look at this. I have on top, factor first. How do I know that I can possibly factor here? You see addition and subtraction. Okay, so we can try to factor. When you factor, and we're just going to deal with the numerator right now. We're just going to deal with what's on top right now. What's the first thing you always look for in factoring? Greatest common factor. Is there anything in common here? There's an x. So let's take the x out first. So if we take an x out, we have 1 left over plus 4. So you get x times x plus 4. Alright? On bottom, there's nothing in common. It's a binomial, so it has to be a pattern. Right? It's the difference of 2 squares. How do you factor the difference of 2 squares? Come on. Two sets of parentheses. What goes in them? X plus 4 and x minus 4. They have to be opposite signs. Now, how are we going to reduce after we factor? Watch this. In order to reduce a rational expression, a fraction with algebra, you're going to cancel out like factors. Like factors. Factors are things that you're multiplying together. In the numerator, I have two factors. I have an x and a group of x plus 4. So I have two factors. An x, that is one factor by itself, and an x plus 4, which is a totally different factor. So there's two factors in the numerator. In the denominator, I have two factors as well. I have two groups that are multiplied together. But there's two factors. There's an x plus 4 and an x minus 4. Now to reduce this, you're going to cancel out like factors. Do you see any factors that are exactly the same? What are they? X plus 4 and x plus 4. Now remember, it goes to 1. So on the top, I have x times 1, which is x. And on the bottom, I have 1 times the group of x minus 4, which is x minus 4. Now, I'm going to throw a word of caution to you here. Hear me now or regret it later. This x will not cancel this x. The only time you can cancel is if you have factors, things that you're multiplying together. In this particular problem, do you see anything being multiplied together? No. There's nothing being multiplied together on top. There's only one thing up there, it's an x. There's nothing being multiplied down here. Right? That says x minus 4. It's not being multiplied. So that's a group. That x will not cancel that x. And if it helps, keep that in a group. The only time you can cancel a group is if you see another group exactly like it somewhere else. Either top, bottom, diagonal. Okay? The only time you can cancel groups is if you see another one just like it. Alright, so let's look at the one on the bottom. I know that I'm going to try to factor. So on the top, in the numerator, I see a 6 that's in common. I see an x that's in common, and I see a y that's in common. So if I bring out a 6, all that's going to go to 1. If I bring out an x out of x to the third, I'm left with x squared. If I bring a y out of both of those, the y's just go away. So over here, it's minus 1. Do you see that? You're taking x cubed y, 6x cubed y minus 6xy. And you're dividing out the common factor. So if I divide out here, the 6's go away, the y's go away, and because of the previous slide, you have an x squared on top. Minus anything goes over itself goes to 1. So you get x squared minus 1. Alright, on the bottom, there's an x in common. So I'm going to have x squared plus 5x plus 4. Now, at this point, do you see anything that will reduce? Where? Yes. This x and this x will cancel out. Reason being is because that is multiplication and that is multiplication. They're factors. We're multiplying. So this x and this x will cancel out. Well, what do you notice about this group right here? Good job. So that's going to be x plus 1 and x minus 1. What do you notice about this group here? How would you factor that? It's a trinomial. Your leading coefficient's 1. What are the signs going to be? Good. And then x squared, you're going to bust into x and x. What can you multiply together to get 4, but add together to get 5? 4 and 1. Now, do you see anything that will reduce? The x plus 1 group. Good.
Is that one x on the outside supposed to be?
No. Thank you. Alright, so we're going to have 6y times x minus 1 on top over x plus 4. And I would leave it in the group on bottom. Now this is your answer. Don't turn around and distribute 6y back through. This right here is going to be your answer. All right. So what I want you. All right. So here we go. So for the one on top, you can go off to the side and work on these if you want to. The first thing I'm going to do, most people are doing bottoms up. So we're going to have on top n squared plus 6n minus 40. And then when you factor those two, you're going to have n plus 10 and n minus 4. But then you got to turn around and divide that 5 back out. So here you're going to have n plus 2. And here this won't reduce, so you'll have 5n minus 4. So we have 5n minus 4 times n plus 2, or vice versa, it doesn't matter. On the bottom, we're going to do the exact same thing. So we're going to have n squared minus 3n minus 40. This time, we're going to have n minus 8 and n plus 5. So then if we divide a 10 back out, the first one's going to reduce to n minus 4/5, and this one's going to reduce to n plus 1/2. And if we bring the bottom up, we'll have 5n minus 4 times 2n plus 1. All right, and then the 5n minus 4s will cancel out to 1, leaving us with n plus 2 over 2n plus 1. All right, the second problem, same thing, bottoms up again, so we'll have n squared minus 7n plus 12, and then we'll factor this and we'll get n minus 4 and n minus 3, and then we'll divide the 6 back out, and so we'll have 6n, no we won't, we're going to reduce. We're going to have n minus 2/3 and n minus 1/2. And so we'll have 3n minus 2 and 2n minus 1. That's the numerator. All right, on the bottom, we need to put this in descending order first. So we're going to have negative 15n squared plus 10n. I don't want a negative leading coefficient, so I'm going to factor out a negative 5 here. And so when I do that, I'm going to have a negative 5n actually. So I'm going to have 3n plus 2, minus 2, sorry. So the denominator is going to be 5n times 3n minus 2. So these two are going to cancel out, and you're going to have 2n minus 1 over 5n.
Negative 5?
Yes. When you multiply and divide these rational expressions, when you multiply though, what you're going to do is look at number 1. It says factor first if possible. Sometimes you'll be able to, and sometimes you won't be able to. How do you know? In order to factor, you must see what? Addition and subtraction. In order to factor, you must see addition and subtraction. Well, in this particular problem, we don't see that. So we can't factor at all here. But you can just start canceling things out. What do you want to cancel out first? Okay, this x will cancel this x. And remember, it goes to 1. Okay. What else? 3 will go 1. 3 will go into 9 3 times. What else? Good. 4 will go into itself 1 time, and 4 will go into 8 2 times. What else? This 1y will cancel one of those, so you'll still have 1 left. Now, on the top, we have 1. This all went to 1. All this canceled out to 1. We have 1 times 2y. Because to multiply it out, you're going to multiply straight across. So 1 times 2y is going to be 2y. And then you're going to have 1 times 3, which is going to be 3. Now, if you multiply and you still have something that will reduce, don't fret over it, just reduce it. Okay, it's no big deal, that just means you missed something in the problem. Alright, look at these. Look at this. Can I factor the y? Not cancel, but factor. No, you don't see addition and subtraction. Can I factor x plus 2? No, but I see addition, but there's no factoring to be done. What about x squared minus 4? That's the difference of two squares. So that's going to go into x plus 2 times x minus 2. And then, of course, that goes away, and the y squared won't factor. Now, everything's factored. That's step number 1. Factor everything that you can. Now you're going to go and reduce everything that you can. Well, the x plus 2 group will cancel. And this y will go to 1. And it will cancel all but one of those. So a y will cancel a y. Alright, so on top, I have 1 times 1, which is 1. And on bottom, I have y times x minus 2. And that's your answer. 50% of you, if I had asked you to work this problem without showing it to you, 50% of you would have told me your answer was y times x minus 2. That's the denominator. There's still a 1 on top. When things cancel out, they cancel a 1. Okay, so let's work on this one on the bottom. Right here. What do you see?
X squared minus X.
Right, so how will it factor? There's an x in common, so we're going to take that out, and you're going to have x minus 1. Okay, let's go to the bottom. X plus 5, will that factor? X plus 5? No, so we're just going to bring that over. Okay, let's go to this numerator. It's a trinomial. There's nothing in common, but it'll go into what? Does anybody know? X plus 4 and x plus 1. And then on the bottom, what do you see?
An X squared.
There's an x squared in common, so we're going to bring that out. And left is the x squared minus 1. Now what? Yes. That's going to go into x squared times x plus 1 times x minus 1. Alright, so everything's factored. That's your first step. Your first step is to factor each individual numerator and denominator. Now that we have this, let's start canceling things. We have an x minus 1. We'll cancel an x minus 1. We have an x plus 1 that will cancel an x plus 1, because remember you can cancel diagonally and up and down. And let's write what we have left over. On top, we have an x times x plus 4. I think it'll be easier for you to see if we just rewrite it. And on bottom, we have x squared times x plus 5. Now that hopefully you can see that this x will cancel here. So you have x plus 4 over x times x plus 5. And nothing else will reduce. Nothing else will go. What is it? What?
What about x squared? You got x over x plus 5 and x plus 4 over x squared.
Mm-hmm.
Cancel one of those x's out.
Right here. There's one on top and 2 on bottom. So this one will cancel one of those. Is that better?
Yeah.
Okay. Alright, the last thing I want to talk about, which will reinforce this, is division. Okay? When you see a division problem, if you'll look on those problems where I'm picking and choosing problems on page 173 and 174, if you see a division sign in between your fractions, you're going to keep, change, flip. You're going to keep the first one as is. You're going to change your division to multiplication, and you're going to flip that second fraction. Always. Keep, change, flip. So this is going to, your very first step. Your very first step is going to keep the first one as is, change division to multiplication, and then flip that second fraction. And now you're back to multiplication and you know where to go. Alright? So it's keep, change, flip. Don't ever confuse yourself by saying, well, do I flip the first one or do I flip the second one? It's always keep the first one as is, change division to multiplication, and flip that second fraction. Always. And then from here, like I said, you're back at multiplication. So we're going to reduce where we can. I'm going to reduce the 8 with a 24. And then I'm going to reduce these two x's with an x squared up top. And then I'm going to reduce these 3 y's with the y cube on bottom. So I'm thinking on top we're going to have 16x squared over 27y. And I don't see anything else that'll go. So when you see the division sign, it's keep, change, flip. Keep, change, flip. And then you just go back to multiplication. Okay? So the multiplication rules are the same. If you see addition and subtraction, factor first, then reduce. I didn't have any addition and subtraction, so you're not going to factor. You're just going to straight up reduce. Okay? We will pick up here Wednesday.